Hello and welcome to Unit 3 of Basic Electrical and Electronics Engineering. We learn what is a diode, symbol of diode, applications of diodes, the PN junction concept, and its summary. A diode is a two-terminal semiconductor device. It has a very special property. It allows current to flow in one direction, but blocks it in the opposite direction. This makes it act like a one-way valve for electric current. Its most important function is rectification, that is, converting AC into DC. Because of this property, diodes are widely used in power supplies, electronics, and communication systems. The symbol of a diode is quite simple. The triangle represents the direction of current flow, the line represents the cathode, which is the negative side, the other end is called the anode, which is positive. When the diode is forward biased, current flows from anode to cathode. Diodes are extremely useful in many applications. They are used for AC to DC conversion in rectifiers. They help in voltage regulation to keep circuits stable. They are also used for signal demodulation, which is important in communication systems. In addition, diodes are used in protection circuits, as well as in light-emitting diodes, LEDs, and photodiodes. The diode is formed by joining two types of semiconductor material, P-type, which has holes, and N-type, which has electrons. At the junction, these charge carriers recombine and form what we call the depletion region. This region acts like a barrier, creating a potential difference across the junction. In the absence of any external supply, the diode remains in an equilibrium condition. The depletion region is the area around the junction where no free charge carriers are left. It is formed because electrons and holes recombine at the junction. This region acts like an insulating barrier, preventing current flow. The width of the depletion region depends on the doping concentration of the P and N sides. To allow current to pass through the diode, we must overcome the barrier potential created by the depletion region. For a silicon diode, this potential is approximately 0.7 volts. For a germanium diode, it is about 0.3 volts. Only when this voltage is crossed, the diode will start conducting current. In the forward bias condition, the positive terminal of the supply is connected to the P side and the negative terminal to the N side. This reduces the depletion region, allowing current to flow easily. In this state, the diode conducts current and can be used in rectifier circuits to convert AC into DC. In the reverse bias condition, the positive terminal is connected to the N side and the negative terminal to the P side. This increases the depletion region, making it wider. As a result, only a very small leakage current flows, and the diode acts like an open switch. This property is very useful in many electronic applications. Let us quickly revise what we have learned. A diode is like a one-way switch for current. It is made by forming a PN junction, which creates a depletion region and a barrier potential. When forward biased, the diode conducts current. When reverse biased, it does not conduct. This simple device is the basis for important applications like rectifiers, regulators, LEDs, and photodiodes. That brings us to the end of this session on the PN junction diode. In the next video, we will go deeper into the VI characteristics of a diode and study its practical applications in circuits. Thank you for watching and see you in the next session.